All right, let's go over this question, number 21. As an alternative to experiment 2, the chemist can improve the yield of polymer obtained in experiment 1 by increasing the amount of. So let's rephrase this. What it's really asking is, how can the chemist improve upon the yield of polymer in experiment 1? In other words, how can the chemist make more polymer? What the heck is the polymer? Let's go over here. This here is the polymer. How can you make more polymer, right? And the first thing that should go off in your head is Le Chatelier's principle, right? And how do you make more? If you want to make more of this, what you can do is you can either, there's a couple ways to do this. You can either increase the amount of NCDP, that's increasing your reactants. That's CDP, right? That's increasing your reactants, right? You can also remove. You can decrease the amount of product. In other words, if I start removing a bunch of this hydrogen phosphate here, the reaction will shift to the right, and it will also make more polymer, which is in yellow, the CPN, right? What you cannot do is you cannot increase the amount of catalyst, right? Because what the catalyst does, the magnesium or any type of catalyst, is that all it does is it speeds up the reaction by decreasing the activation energy. In other words, it'll make the product a lot faster, but it's not going to increase the quantity of the product, right? In other words, it's not going to make more CPN polymer. It's going to make it a lot faster, but you're still going to make that same quantity, right? So what do you think our answer is? And the answer is choice D. Just let me use a nice little choice D is your answer. Let's go over this one over here. Which of the following expressions gives the equilibrium constant for the reaction shown in equation 1? Let's go over to equation 1, and we have to find the equilibrium constant, right? One thing about the equilibrium constant, right, is that it is the concentration of products over the concentration of reactants. And we'll do an example, right? What does this mean in reality? It means that at equilibrium, right, in other words, if you look at this reaction over here, I'm going to erase this just to make it cleaner. At equilibrium, the rate of the forward reaction, right, in other words, the rate of making polymer and hydrogen phosphate is going to be equal to the rate of reaction in the reverse direction. In other words, at equilibrium, the reaction doesn't stop all of a sudden. It's just that the rate of the forward reaction is equal to the rate of the reverse reaction, right? And at that state, what is the ratio of products versus reactants? Do we have more products at equilibrium, or do we have more reactants at equilibrium? And to figure that out, you have what you call the KEQ, the equilibrium constant. Let's go over here, right? We're going to do products over reactants, right? So if we look over here, let's look at the products. That's CPN. Well, before we do that, I want to just tell you what are the coefficients among each of these. N is the coefficient in front of the reactant, which is the diphosphate, right? Just going to do it over here. This is 1, and this is N, right? And we're going to see how that plays into the equilibrium constant. right? If you look over here, what are the products? So it's Cp, the concentration of CPN, that's going to be raised to the first power, right? Because that's the coefficient here. And then we're going to multiply that by the concentration of hydrogen phosphate, and that's going to be raised to the nth power because that's the coefficient over there, right? And that's going to be over the reactants, which is CDP right over here. And that's going to be raised to the nth power because that's the coefficient of the reactants on the left-hand side. And let's see what this maps onto. I'm just going to take this. I'm going to drag this down. All right. And we're going to see which one does this map, but which one does this map onto nicely? Which answer choice? Right? And that looks like it is choice. Choice A.